everybody. Sorry, I thought I'd be able to come back in today. I'm just not feeling so well. So we're going to go over the remainder of lesson 1. We started looking at all of the exponent rules yesterday, and we practiced several questions that went through the multiplication rule, division rule, power of a product, power of a quotient, and then our fractional exponent rule, which is our power over root. And remember, it can be really written two ways. So that index number, whatever the root is, becomes the denominator of the power, and whatever that exponent is stays up top. So what we're going to do is we're going to go through lesson 1. We did look at question 1 yesterday, so let's just revisit it. I want everyone to just take a minute and try to determine which of these expressions is false. Maybe pause the video, and then when you're ready to go over it, unpause. So for each of these, on the left side, we should be raising powers to powers. This is the power rule. So for each of these expressions on the left, I should be multiplying the exponents. What this question is trying to kind of trick you with is the way that these numbers are lined up. It almost looks like you're supposed to multiply the wrong parts. So in the first expression, I'm multiplying 3 halves with 2. So I should be multiplying the 2 with the 3, not with the denominator. So this should really be 6 over 2, which would be x to the third. Now x to the third would not equal a radical expression because that's not a fractional exponent. So choice 1 really is the answer. But just to review, the other choices are correct because x to the third to the 1/4 would be 3 times 1/4, which would give you x to the 3/4. And then I can see my power over root. So that one is correct. So we can move on. Choice 3, 3 halves is the power being raised to the 1/2. So if I multiply those powers, I would get x to the 3/4. So again, here's my power over root in radical form. That's also correct. And for this last one, we have x to the 2/3 being raised to the second. So I would multiply the 2 with the 2, so x to the 4/3. And then this is also correct. Here's my power of 4 over my root of 3. Okay, so let's do the same thing with number 2. Number 2 is asking you for an expression that is equivalent to, which does mean you always have the option in the calculator to use a testing strategy and store a number for x and y. But before you go to that strategy, I want you to try to think about, first, what does it mean just to have the 4th root around this radicand? And take a moment to see if you can rewrite the expression and find the choice that's equivalent using exponent properties. Okay, so if you've had a chance to think about this one, 81 x to the 9th y to the 2nd is being 4th rooted, which means that's the same as raising it to the 1/4. If you're taking the root of an expression, that is equivalent to raising that expression to the reciprocal power of the root. So 4th rooting something is the same as raising it to the 1/4. Now I would use the power of a product rule, remind myself that 81 has an exponent of 1, and I'm going to multiply all of these powers with 1/4. So I should get 81 to the 1/4, x to the 9/4, y to the 2 over 4. Now 81 to the 1/4, you can do that in the calculator, but that should give you 3 x to the 9/4, and then I can simplify y's exponent to be 1/2. So this should give us choice 1 as well. Okay, let's move on to number 3. Okay, so this is also asking us what's equivalent to. They tell us b is a number greater than 0, so that's just to ensure that our base, which is 3 times b, doesn't become negative or 0. And d is some positive integer. So they want to know how can we find an equivalent form of 3b raised to the 2 over d. So take a moment to pause the video and see if you can write this as an equivalent form and see if you can find your choice. Okay, so power over root. I should have a root of d and a power of 2. Now with the power, you could see it inside or outside the root. Either form would be correct. So let's just look at the choices to see which one they wrote. So it would not be in a fraction. And I see the correct choice as 4. So they did put that root, that power of 2 on the outside of the root as opposed to inside of the radical, and then notice choice 2 would be the opposite if they put the 2 in the root and d is the power. So it's important to remember power over root because they're going to give you that distractor choice. Okay, now number 4 is an open-ended question. This would be like a 2-point question on the test. Take a moment to see if you can use exponent properties to simplify this fraction and then leave your answer in radical form, in simplest radical form. So pause the video, do your best, and then we'll go over it. Okay, so initially in your numerator, you can't really do anything, so I'm just going to rewrite this. 2 times x to the 3 over 2. And then in the denominator, remind myself I have 16 as an exponent of 1, and I'm going to raise both of these powers to the 1/4. So I should get 16 to the 1/4 and x to the 4 times 1/4, which would be x to the 1st, right? So our power rule tells us multiply those powers when powers are being, raised to other powers. 16 to the 1/4, this number is 2. So let's just rewrite this one more time here. So now I have 2 divided by 2. I'm just going to cancel that. And I also have x to the 3 over 2 divided by x to the 1. So now this is my quotient rule. I'm going to subtract those powers. So this should be, not that you have to write this, but this is what we're doing. And just to think about, I could write this as 2 over 2 because I'd have to have equivalent denominators, right? Common denominators. So this should give me x to the 1/2, which in radical form would be the square root of x. You don't have to write the 2 here and the 1 here, but you can. Because again, this was my power of 1 over my root of 2. Okay, and then the last question. Again, pause the video for a moment and just read it. See what you make of it. It It would also be a 2-point open-ended question, and then we'll go over it. Okay, so Kenzie believes that for x being a value greater than or equal to 0, the expression the 7th root of x squared times the 5th root of x to the 3rd would be equivalent to the 35th root of x to the 6th. We're trying to determine if she's correct, and we have to justify algebraically. So we have to use properties of exponents to see if this makes sense. So we discussed something similar to this yesterday. We can't multiply radicals that have different indexes, like these are just different values. So I can't start out by doing anything in radical form, so I'm going to rewrite both of these expressions in fractional exponent form. Again, power for both of them, my power over my root. Let's rewrite that. Okay, so now that I've done that, I can use my product rule, which tells me when I multiply like bases to add those exponents. Now for this, you could come up with a common denominator if you want to, but you don't need to. Just go to your calculator, add 2/7 and 3/5, and you should get 31 over 35. And again, if you're wondering where that comes from and you didn't use your calculator, you'd multiply this by 7 over 7, this fraction by 5 over 5. So what you're essentially adding together is 10 over 35 plus 21 over 35, which is where the 31 over 35 comes from. Now, Kenzie put her expression in radical form, so let's do that. My power over root. So this would equal the 35th root of x to the 31st power, right? So that would be my final answer. She got the 35th root of x to the 6th. So no. Is she correct? I would have to state no. And then this work is my justification. So this would receive full credit. And just to see like what she did, she multiplied those exponents, 2/7 and 3/5, instead of adding them, which is a common mistake. So we have to remember with the product rule, if you're multiplying like bases, to add those powers. Okay, so at this point, I would love for you to take some time and try the practice questions. The practice questions have answers at the end of your packet, and then homework 1 is due on Monday. So please take some time, work on the practice, work on the homework. Have a wonderful weekend, and I'll see you on Monday.